Okay, so I'll just make a short announcement. I think Frank has been at pretty much every TUG conference that I've been at, and that goes quite a long way back into the late 1990s. And he was probably going to them even before then. And most of the time he gives a talk about LaTeX 3 or something like that, just like he's going to do today. So here's Frank, and yeah, if you're ready to go, take it away.
Just one word up front. This talk is pre-recorded because we were asked to do so, and as many other people said, kind of a new experience. It's done on a ship, so I'm sort of swaying from one side to the other. Sorry for that. The reason is, of course, not on a ship, but usually I walk around on a stage, and had to glue my feet to the floor, and the result is the rest of the body is moving around on the stage, and yeah, that's it. Okay, I think you can just let's go and we see what comes through. Good day, everybody, and welcome to my talk. I've given a few talks in my life, but I never tried to pre-record one, so please bear with me and the fact that I'm somewhat struggling with the tools and the missing audience. My talk is titled, A Look at the Upcoming Years, but in order to understand why we are proceeding in a particular way, it is important to understand where we came from. I therefore divided the talk into two parts. First, a short and biased history lesson, and then an outlook of the immediate and the midterm future. So where are we coming from? Well, everything began more or less 30 years ago in Stanford at the TUG meeting in '89. And yes, this is really my picture, or so I'm told. There I gave a talk in front of Leslie and Don and was boldly picking on deficiencies of LaTeX 209 and how to improve them and why it is necessary and so on. I had been pestering Leslie with bug reports and corrections in the previous years, so it wasn't really new to him. To make a long story short, after several lengthy meetings with Leslie, he passed on the maintenance of the future development to Chris Rowley, Rainer Schöpf, and myself. He wanted initially to consult with us, which he did, and then retire from any future work, which he did too after a while. I guess there's a lesson here that I still have to learn. So this was really the birth date of the LaTeX project, August '89. But we could never have done all this, what we did, by ourselves. So we soon recruited additional members. So here are the folks to praise or blame, depending on your point of view, who brought you LaTeX 2e more or less in the same way you're using it today. I guess few of them will need introduction, but you may not know the faces. So here we go. From the left, we have Rainer Schöpf, David Carlyle with Chris in the background, Johannes Brahms, Alan Jeffrey. On the second line, Denise Touchier, Michael Downs, and Robin Fairbanks. For Denise, I was unfortunately not able to unearth any decent picture from those days. I mean, you have to remember this was way before digital cameras and smartphones, so snapshots haven't been quite rare. Anyway, we have been quite busy in those early days, and around '93, we had a complete LaTeX 3 format available that was actually able to compile its own programmer's guide. So why I'm calling it useless on the slide? Well, simply because you were in the danger of dying of excessive caffeine consumption by waiting for all the small documents to compile, let alone something like a big guide like this one. Basically, we have been just several computer generations too early, or maybe we have been lousy programmers, or both. For example, we invented back then a system comparable to cascading style sheets. That was way before that appeared in browsers. but all our ideas required much more computing power than was available on typical machines on those days. So in the end, we gave up and decided it was a nice but an impossible dream. Instead, we took all the extensions and improvements we had made to LaTeX 209. We developed the graphics and color abstraction, and we bundled everything under the name LaTeX 2 Epsilon. And this was then promoted as the newly revised LaTeX standard. Leslie went on and updated his LaTeX manual, and Michel Goossens and myself, with the help of Alexander Samarin, produced the first LaTeX companion. That is, to the old-timers, also known as the doggy book, I guess. LaTeX 2E, or LaTeX 2 Epsilon, had a fairly shaky start. And that was largely due to the fact that there was a small but a very vocal group that argued very loudly against using it and suggested to everybody to stay with LaTeX 209 instead. The reason that was given was, well, nobody needs those new 8-bit fonts with pre-composed foreign characters, which you can do nicely in TeX without just using the accent primitive. And they take up a huge amount of unnecessary space on your hard disk, so don't use it. In the end, however, it actually took off like a rocket, and that was largely due to all the other goodies it offered and the fact that there were many users around the world that were actually waiting for the ability to use additional fonts, to use hyphenation in different languages, etc., etc. So for me, this was an important lesson to see how close failure and success can be. You just need a small group, and then it becomes questionable what is going to happen. What you see on the slide is a selection of books that appeared in the first 2 years or so after the event of LaTeX 2 Epsilon. So let's fast forward through the next decades. At some point later, we decided to release some of the work that we did for LaTeX 3 as a package on C10, basically just to preserve it in case, so to speak. That action got a number of younger people interested. First Morton, later Will and Joseph. They pushed for updating the language, using the language, and so we did again some work on it. The computers were faster, and then there were bigger applications written, such as font spec in the language. And at some point, the language was stable, and so we announced it for being fit for general use. During that time, the team got new members, but we also lost some of the original members. From that team, only Chris, David, Johannes, and myself are still active. Michael died very young, and Alan, Dennis, Rainer found new challenges, and Robin eventually retired from active work. So here are the new faces in the order in which they joined over the years. Again, most names will be familiar to you, I guess. The first one in the first row is Morton, then Javier, who took over the work on Babel from Johannes, Will, Joseph, and Bruno, the man for the impossible tech code. That's amazing, really, what he can achieve with tech. On the second row, we have Jonas, who designed and implemented the LaTeX Project website for us. Then Enrico, probably known to everybody who ever went to Stack Exchange. He has the highest reputation on that platform. Ulrike, Philippe, and Marcel. So now with Expo 3, the LaTeX programming language, being stable around 2012, we started promoting it. And Paulo Cereda was very kind and designed a new logo for it. I do hope he's in the audience. Paulo, this slide is really just for you. Big thank you from me. I love this bird and I love the message. To indicate that we were moving into new waters, I pushed for using the hummingbird also as the official logo for LaTeX. At some point we made that switch. Some people were concerned that we are not associating LaTeX any longer with some sort of a line, and that will confuse people, but it seems that we are fine. The logo was positively received, and nobody is questioning that anymore. So let's return to some further cornerstones from the past. Big step was taken in 2015. We announced a new bug fix and enhancement policy. Before that, LaTeX 2E was essentially kept unchanged. Even serious bugs were not fixed. Or they were fixed in an additional package called LTEX 2E, and that one could then be loaded or not loaded. On one hand, that meant great stability, but it also meant that only very few people would add that package, and the majority would stay with the buggy version. Now, in the beginning, that was fine, but over time, it became a burden because no other package could rely on things being fixed or not being fixed. So all the packages out there had to basically program around the situation and have different code paths depending on whether fixes were applied or not applied. So eventually we decided that we switched the approach and that fixes get always applied by default. So everybody receives them. And instead, we now offer a way to opt out of the fixes by providing a mechanism to roll back the format to an earlier state, if that is ever necessary. Around that time, we also started to bring in external developments into core LaTeX. Two more important examples are the official support for LuaTeX in the kernel. We took over the maintenance and the further development of AMS Math from the American Mathematical Society. But we also went a step beyond bug fixes and integration. We announced at that time that necessary enhancements to the code to keep it relevant would also be presented in most cases as an opt-out and not as an opt-in solution. So you get the enhancements by default. A good example is the switch from legacy 8-bit code pages to Unicode, or more precisely to UTF-8 encoding. That happened in 2018. There the LaTeX release switched from the default input encoding of LaTeX being the sort of 7-bit and nothing else to UTF-8. And I guess few people have noticed any ill effects with that document. There are certainly some border cases where it broke all the documents. Any change you do has that effect if you have millions of documents out there. So in those cases, the opt-out had to be applied for them. But as I said, most people would have noticed nothing other than they are able now to use Unicode characters in their documents without problems. Which brings us to the year of Corona. two important changes happened in spring release this year. One was the modernization of the LaTeX font selection scheme to better support all the new high-quality open-type fonts and their additional font faces like italics, small caps, and so on. The other one is listed on the slide as improved load times for Expo 3. Now, you may ask, why is that important enough to be listed here? Well, the reason is that it really means the following. In other words, the programming layer of LaTeX 3 that we envisioned 30 years ago has now finally arrived inside LaTeX. And that brings us to the immediate and midterm future. LaTeX stayed surprisingly relevant if you think that the original design dates back to the 90s. There are, however, some limitations due to the underlying engine on one hand, and some are due to the design decisions that have been made in the past. Perhaps the most important limitation is that until today, LaTeX is concerned really only with trying to print on paper. Any other usage is either not supported or it is indirectly supported through some packages. But these days, these other usages become increasingly important, and many documents are never printed or only printed as a secondary action. For example, if you look at the hyperref package, it has to redefine half of LaTeX internals and many commands of other packages to be able to achieve its goals. And even that is often not enough. You can only do it with restrictions. The reason is that other packages also try to patch into the same areas. You have, as a result, conflicts and these kind of limitations that are sometimes resolvable by changing the order of packages and so on, but sometimes simply mean it breaks at very strange places. Another important issue is that LaTeX is very carefully in throwing away all the structural information it actually has at its disposal in the document source while it is producing the output pages. The reason here is a bit of historical, because in the early days memory was really low, and so LaTeX got rid of everything that it didn't need anymore for the purpose of printing. So as a result, the PDF or the DVI file that is produced is just a stream of position glyphs without much structural information preserved. As long as your intention is to print the document, then this is all that is required. But if you want to produce, say, an accessible PDF document, then a lot of the structural information and other data has to be embedded in that document to guide the screen readers, etc., and to comply with the standard in that space. With these challenges in front of us today, we are now focusing on the following areas to address them. So we plan to integrate important functionality that is in existing packages directly into LaTeX, so that the users and package writers can rely on them and get standard interfaces for them. Examples for this are the hyperlinking and color specification, but there are several other areas we are looking at. In addition, we plan to provide standard interfaces for some important capabilities that are currently not available at all, or only in some rudimentary ad hoc fashion in some package. Example for this is the hook management system that is planned for the next LaTeX release in this year. And finally, I have listed here a one-liner about tags PDF, which hides a huge project, and I'm coming to that in a minute. So how do we plan to go about it? Well, basically, we have decided that there will be no separate LaTeX 3 product sometime, somewhere in the future, because that would only be usable once it's complete, and that means, in other words, never. Instead, our plan is that we take you on a journey through some gentle refactoring of LaTeX to reach the same target, but do that in smaller steps. And if you think about it, this journey has already started in 2015 with the new bug policy and the rollback mechanism, and then was followed by the switch to UTF-8 to keep LaTeX relevant in today's world. Another example is the new general hook management system for LaTeX that I already mentioned. In the past, LaTeX had just a few very heavily used hooks, for example, like begin document. Every other addition or alteration that was made by a package was done by overriding the existing kernel code, because there was no way to hook into it in defined ways, leading to all these kind of known issues. With the new hook management system, LaTeX, the kernel, and many packages will get a large number of hooks, and into these hooks, packages can add in a controlled manner their code, avoiding this patching of commands and the resulting issues. So let's finish off this talk with a little bit more on detail on the biggest project that I was alluding to earlier. There's been groundbreaking work done by Ross Moore and other people in the last years or the last decade in the quest for enabling LaTeX to produce accessible or more generally structured and enhanced PDF documents. The unfortunate problem with all these attempts was that they ran into the issue that it is next to impossible to patch the current LaTeX kernel and all the packages out there and obtain reliable results. What you obtain are results that are very fragile. Any change in a package and that will break your code. You need to enforce severe restrictions on the document content, and even then it requires the user to do a serious amount of manual work, largely because there is no machinery and no interfaces in LaTeX for it. Our plans are therefore to learn from this work and provide the necessary interfaces directly in LaTeX so that this fragile and incompatible patching is no longer necessary. What we have undertaken so far is to produce a feasibility study and develop a detailed project plan to reach this goal. This is a multi-year undertaking, and it is split into 6 phases. And how long it will take depends really in part on the financial backing for the project. That is, it depends on how much work we can be doing sort of full-time and how much we have to do in our spare time, because we have to work on other things for our living. So it's a question of how much can be financed by sponsors out of the industry. I'm therefore pleased to be able to say that Adobe is sponsoring a fair portion of the project costs, but I hope that we can attract further industry sponsors so that we can keep the timeline at a reasonable length. As I said, the project is split into 6 phases. They are progressing in parallel to the LaTeX releases. That means a phase is expected to take 1 or 2 LaTeX releases, depending on how much time we can devote to the necessary work. The deliverables of each phase are intended to be directly applicable to LaTeX users and to LaTeX developers, so that we can get immediate feedback, but also to make tangible progress towards the ultimate goal. Phase 1 is already well underway, and one important deliverable is that we are introducing the general hook management that I already mentioned. The main goal of phases 2 and 3 is to provide automatic tagging for simpler documents, excluding more complicated structures as mathematics and tables. This will be initially delivered as a prototype implementation, as an add-on package, so people can use it and can experiment with it, can produce documents with it, but it is not directly in the kernel. It's overwriting the kernel, but since we control the kernel, it will be not in conflict with the kernel, so all the adjustments are done by the package will match with the current kernel version. The main goal then of phase 4 is to incorporate that code into the kernel itself. Now, this has to be done very, very carefully and cautiously to keep everything working well, whether you want to use it or not want to use it. So there's no negative impact for the users processing their legacy documents. And this is why we expect that this will need a full release cycle for doing that integration. Maybe more. With basic tagging available, the focus of phase 5 is then to provide extended support for tagging, adding tables, adding formulas, and other support elements that we haven't covered earlier. Furthermore, we intend to have interfaces for specifying alternate text and add those to all the relevant elements, so that you can specify that properly in your source and then get it added to the PDF document. Finally, phase 6 will then focus on providing additional support for the relevant PDF standards. Well, as far as that is possible using LaTeX without post-processing the resulting PDF. I mean, some things cannot be done by LaTeX, some things in the standards are visual and not mechanical, if you like. Adding kernel support for associated files and outlines is also planned in that phase. Additionally, to those 6 phases, which are basically containing tasks that are largely understood from a technical perspective, there are a number of tasks that require real research first. And this research is going to be carried out in parallel to all the other work and might affect, depending on its outcome, of course, the later phases or require some additional tasks in the phases. Depending on that result and the financial support, the project timeline is expected to be somewhere between 3 and 5 years. So this brings me to the end of my talk. Clearly, that was just a short glimpse of our plans for the immediate and the near-term future. The feasibility study, for example, and its implication and dependencies is about a 40-page document, and I touched on it in 2 or 3 slides. In the near future, we will therefore publish more details and on the plans and also on the intermediate results. as a first result from phase one, as I mentioned before, is that you can now already take a look at the new hook management system, provide your feedback for consideration before it gets introduced in the full release. The lines there show you if you have an up-to-date tag live on MikTag, how to get to the documentation and how to use it. With that, thanks for listening.
Okay, well, thanks, Frank. And question and answers. If you can get to the Q&A, then please do that. Otherwise, use the chat. It looks like we do have a question here in Q&A from Aman. So, Frank, are you able to get to the Q&A?
Yeah. If it doesn't vanish on me, I sometimes it seems to vanish. I don't know who can move the things to the next block. But anyway, yeah. The first question from Aman is there any plan to add a feature to reflow text from a single macro into multiple boxes of various sizes and so on? Such layouts are pretty common in document typesetting, and humanity's absence of a clean interface to do this is likely the single most impediment to open world LaTeX for more complex layouts. The answer to that first question is yes, I do have plans on that. That's actually a different project. And how much I'm going to devote my time on this in that phase of the TAG PDF project, I don't know. I think it is a very highly important one for certain areas of possible LaTeX use that is taking new grounds, as mentioned in the question. And it is an extremely fascinating area because a lot of that is actually computer science research. I don't know, some people may know that I did research work in that area, or some of that area, in the years 16, 17, 18 around. They are published at the document engineering conferences, ACM conferences, and I was quite pleased to what I managed to do there on a level of prototypes for some stuff there. But there is much more necessary, and yes, so I'm looking in that direction. I think it is actually very important, but different from what we are currently focusing on. And I'm not sure how much can be done in parallel. So, second question, will a low-level Lua tag access tagging interface be released first to try it on custom layouts and document with parallel text streams? Well, how we are going to publish intermediate results is a little bit partly up in the way how the project is going. We are certainly, and this is the intention that I was trying to convey here, we are certainly starting off with producing the machinery for tagging and so forth, first as, if you like, tryout work, and getting feedback from those people who are interested in using it for their own documents, and in an early stage where it is still sort of fluent. The best example here is already the work that Ulrike is constantly sort of evolving with tagged PDF or PDF tags. I can't remember what the name of the package is. Package that is intended for experimentation and for feedback for us, but not meant as a final version. And so we will grow this kind of work in that form, and so we will have releases where we have direct usage specifically for LaTeX as well as specifically for the PDF tech engine as far as we can make it work there, which are sort of on the way and for trial. If I haven't answered the questions, then please just write something in the chat further down. So anything on chat, because that was it, I guess. Can I see this? 32 messages. How am I going to go through those? Wasn't there somebody looking at it before? Okay.
I don't
Where
see
does it
32
start?
messages.
Huh?
I don't see 32 messages.
Well, I probably didn't look in the older ones, but that's possible. Woo the logo. So this is still in the talk.
Yeah.
It's a nice future.
Yeah, here's a new one.
We hope so. Okay.
One from Tyler Ziegler in the Q&A.
Yeah. In the banking governance area, more and more we need an integration of LaTeX and databases. Yeah, this is not really a question, that is a statement. But yeah, I agree. Again, I think, personally, well, I'm a little bit surprised how well LaTeX is sort of doing, much better than I would have expected it after such a long time of being in existence. But beside that, there are areas where new fields are, and there are areas where it actually can or could play a huge role. And certainly something like database publishing is at the core of having an automated system at the back end. And Patrick earlier in his talk was actually showing sort of, well, not using LaTeX directly, but using basically a programmable system at the back end where you can do a transition which is to 100% automatic. And tech and LaTeX is at the core the right kind of system for doing these kind of things. It doesn't have good integrations, I agree with that. If you look at the open source sort of standard LaTeX, because that wasn't the focus of LaTeX in the past. But it is certainly an area where it would play a very high quality role once you, in terms of what it can achieve without human intervention compared to what other systems possibly could achieve. But yes, there may be the need for, or there is the need for having better interfaces to actually address sort of the output that comes out of a database in a way that you can automatically use it. And right now there is no such thing. I mean, speed data is an example where a similar system is actually doing that. You get XML from one side and you end up with PDF on the other side, and the user doesn't do anything other than connecting the two. So there's another one. Yeah. Okay. Please do that. Thilo is thinking he wants to get in contact because he thinks he has a nice solution for it. Well, okay. Anything in the chat or anything else?
Yeah, there's a conversation going on there with Ulrika and Martin Rookett, but you might want to just have a glance. And then here's another one. Tyler says he's from Frankfurt. That's an easy contact.
Yeah, except that we all need masks these days.
Yeah.
I should have put one on actually. I just got a mask sent from Japan, which is pretty nice. So something like this. Came this morning, of course, like this, I guess. Anyway, yeah. So, more question. There's a fourth, or is this an answer? Okay. Yeah, if there aren't any more questions at this point in time, and maybe it was overwhelming or boring, I don't know, either or both. Thank you for having me presenting that. We are all looking forward to make this project a reality, and as you know, we will have to talk a lot about how things can be improved, like we did in the past.
Yeah. Absolutely. Well, you'll get a few ideas from my talks tomorrow. But
absolutely, we know that. I mean, we are not. It's not like we are the first time in contact with you. And then, in case I didn't make that really clear enough, it is not Ross's programming or anybody else's programming in this space. It is really a question of if you don't have an underlying infrastructure, you can struggle through it, and it's amazing what is possible if you are prepared to struggle through it. The problem is if you want to get this through the method, the huge user base that we have, it has to be automatic. They just need to push a button like they do now. If they run it on Overleaf or anywhere, what outcomes is what just through the input and not through additional sort of work they currently, for the reason I tried to outline, actually have to do. So yeah, we're looking forward and making this world in that direction a little bit more easy for everybody, hopefully. What is Chris saying there? I just saw a chat coming by.
Yeah,
on the iPad, it's not so easy.
Okay. He's joining in with the previous one from Ulrika about PDF tagging. And
well, if Ulrika or anybody from the team wants to join in, we can probably get them. What is this? May I repeat my question? Are there other areas? Are there other areas of planned improvements in LaTeX kernels? For example, tables are an area that could be improved in LaTeX. Table sense spanning multiple rows or columns with color. Yeah, this is one of. I think I saw the question from. There was another question, maybe from Jim or so, that I maybe was in the chat as well. What are the research areas? Well, this is one of the research areas. Yes, we will certainly have to improve, for example, the table interfaces, and potentially, not really potentially, we will probably have to come up with a different interface, which is, if you like, incompatible to old tables. And if you want to have structured PDFs, then you have to use the new interface rather than the old one. And why is this a research area? It is a research area because it has to be done right. And we have a lot of different attempts that we see in the tech world and in other parts of structured structured data handling, and we have to find a good solution to it, and then of course also implement it. So yes, we will look into other things that do not at the directly seem to be connected to something like enhanced PDF, but they are implicitly connected to it, and they will therefore be addressed as part of the thing. And then there are the other areas which are potentially only not directed at all, but will also be not forgotten, because at least for my part, I'm a huge very much interested in a design layer for LaTeX, which is part of the LaTeX 3, the original LaTeX 3 architecture design. And having decided to move away from the idea that we can make a jump to a separate product called LaTeX 3, and then hope that this is good enough for anything at the beginning, and instead going through a gradual improvement of the current sort of LaTeX in use. One thing that is on the agenda for that general progression is, of course, document macro layout interfaces. In other words, page design, the multiple flows, and so forth on. So this is going to be in the loop as well. The other research area, as a big example to answer Jim's question, what are research areas that we already sort of know about as far as the project goes, is the question of how to best handle mathematics. I mean, there's one thing about having one solution. The other is what is actually being needed in the fields. And in our opinion, this is an area where a lot of groundwork has to be done first to understand what is best, not in terms of what the standards need, which is in some sense very sort of limited, but what is actually best in terms of what post-processing of this additional sort of information is then going to happen, and how to best present this. So that would be an example of another research area where we think we don't understand that yet as a community, and certainly not as a single person people that we are. So that's a comment by Ulrike. That's not a question. Anything else that I missed? Because I can't really read through the chat very well to understand where questions are, where discussions happen. Oh yeah, we need a LaTeX branded mask. We have at least a LaTeX branded T-shirt, if yes, as far as the project team is concerned. Okay, Ross, do you have seen any other questions that I should address? Otherwise,
there's one that's just coming from Martin Ruckert to all panel attendees. Do you implement the new features using PDF specials in the LaTeX code? And does it mean that the new extensions are specific to PDF output?
Well, the idea is that the machinery is a machinery that can handle different output in different directions. So if you have the concept right, I mean, this is many to one, one to many, basically. So we want to have the right kind of data structures and interfaces on the LaTeX side, and we have backends that use this kind of data and information. So it is not just going to PDF. It could go to something like HTML, to other things. And if we get the right kind of interfaces in the first place, then it can possibly even go to output and further processing that hasn't been thought about. I mean, whether that is then in all cases enough, it's another question, but I mean, that's the idea. So it's not PDF really. It is not as a conceptual thing, even though it's called the TUG PDF project by us currently, just targeting PDF in that sense. For example, I mean, an important aspect is metadata handling, and that is completely. I mean, it's important for anything like a good final document, final PDF document, but it's important to anything else where you want to post-use the final output. Okay, if that's all, we have a couple of minutes break now or something. Is that correct?
35 minutes.
Oh, that sounds good. I mean, I still haven't had any breakfast yet.
Okay, well, I suppose, and thank everybody, and as we just